Welcome back to Math 104. Our task is to decide which of the following experiments allow us to represent the outcomes as 5-letter words in a 2-letter alphabet. The first experiment to consider is to guess the answers to a true-false test with 5 questions on the test. Here we can represent the outcomes as 5-letter words. The experiment itself is a 5-stage process where there are 2 possibilities at each stage. At each stage, you can write T or F down on your test paper. So an outcome is an exam paper that you submit, and that exam paper will look like a sequence of T's and F's. What about guessing the answers to a multiple choice test with 2 questions, but 5 possible answers to each question? This is not a job for 5-letter words in a 2-letter alphabet, but rather for 2-letter words drawn from a 5-letter alphabet. Forming a set of answers is a 2-stage process. You have to pick your answer to question number 1, and that's done by selecting A, B, C, D, or E. Then you have to select your answer to question number 2. That also could be A, B, C, D, or E. There are 5 possibilities for how you answer question number 2. So the outcomes are not 5-letter words in a 2-letter alphabet, they are 2-letter words in a 5-letter alphabet. Our next experiment is rolling a 6-sided die 5 times. Now it is true that the experiment is a 5-stage process. Roll the die once, get a certain number. Roll again, get a number. But there are 6 possibilities at each stage. So what you will get is a 5-letter word, if you wish to call it a word, in a 6-letter alphabet, where the letters here, if you want to think of them as letters, are actually numbers. Or perhaps it's easier to think of this if you relabel the sides of the die with the letters A through F instead of the numbers 1 through 6. Then it's clearer what it means to represent the outcomes as 5-letter words in a 6-letter alphabet. The last example here is to survey 5 people in a row, asking them their preferred candidate for president. Now this is a bit of a tricky example. The experiment is indeed a 5-stage process. You ask person number 1, you get an answer. You ask person number 2, you get an answer, etc., all the way up through person number 5. However, it's not clear how many options there are. It's not clear if we're at an early stage in the primaries when there are many candidates running, or if we're down to the general election when there are 2 major candidates running, although sometimes there are 3 major candidates running, and there are always a number of minor candidates running. So this one is quite ambiguous. However, if we were given some background information that everyone surveyed really is choosing between 2 candidates, then there really would be 2 possibilities at every stage, and then our outcomes could be represented as 5-letter words in a 2-letter alphabet. This turns out to be a very important idea in probability, not just writing outcomes as words of a certain length in an alphabet with a certain number of letters, but more specifically, writing outcomes as words of a certain length drawn from a 2-letter alphabet. Since this will be so important for us, let's look at a number of examples. We've already talked about answering a true-false test from the student's point of view, but how about writing the true-false test from the teacher's point of view? Imagine that there is a test bank of true-false questions, and it's possible to construct a true-false test at random. The different possible answer keys are the outcomes. The sequence of correct answers are the outcomes. So if it turns out that true, 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 false, false is the correct sequence of answers, then that's one outcome of the experiment. You could have another exam where the answer key was a different sequence of T's and F's. Another example, watching your favorite sports team compete N times and noting the sequence of wins and losses. Then we can write the outcomes as N-letter words consisting of W's and L's for wins and losses. We're assuming that we're talking about a sport where there are no ties allowed. For example, win, loss, loss, win, 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 loss. That's an outcome for the experiment of watching the team play 7 games and observing the sequence of wins and losses. Another sports example. Suppose that you have 2 specific teams in mind that are playing one another. The experiment could be to watch them play a certain number of times and note the sequence of wins by one team and wins by the other team. So let us imagine that the Yankees are playing the Mets, for example. Then if the Mets win 3 times, and then the Yankees win the next 2, and then the Mets win 2, and then the Yankees win 3, that's an outcome. Another important example is observing sequences of up days and down days in the stock market for n days total, whatever number n is. We can write the outcomes as n-letter words consisting of U's and D's. Thus, up 2 days in a row, down 4 days in a row, these things happen. That would be an outcome of this experiment. Now we're assuming that either the market ends up higher or lower, but never unchanged. An individual stock can very easily end up unchanged from one day to the next, and even the market as a whole. However, we're making a simplifying assumption so that we can use this model, and in fact, this is a very commonly used financial model. Another survey example is a bit less ambiguous than the previous one. Now we're talking about surveying n people and recording their answers to a yes or no question. We're assuming that they all actually give an answer instead of just walking past the surveyor, but we're going to assume that everyone does give an answer. And since it's built in that there are only 2 answers, this is a job for writing outcomes as words consisting of just 2 possible letters, Y's and N's. Another example we'll have occasion to think about is keeping track of random errors. Suppose that on every exam question, the grader makes a random error. Don't worry, I never make errors when I grade. But suppose that on every exam question, the grader makes a random error that is either favorable to you or unfavorable to you. Well, if F stands for favorable and U stands for unfavorable, we can write the sequence of errors made as a word consisting of F's and U's. As we saw earlier when we were talking about rolling dice, there are experiments in which the outcomes can be described as quote-unquote words of a certain length in other quote-unquote alphabets, especially if it's an alphabet of numbers. Thus, if you roll a pair of 6-sided dice, and you're willing to regard numbers as playing the role of letters, then the outcomes can be represented as 2-letter words drawn from a 6-letter alphabet. But once we understand that the outcomes can be written as 2-letter words in a 6-letter alphabet when we roll 2 dice, then the thinking is exactly the same when we roll a much larger number of dice, such as 15 dice. Then we have many stages to the experiment, I won't even write them all. And in each one there are 6 possibilities, so the outcomes can be thought of as 15-letter words drawn from a 6-letter alphabet. This process of representing outcomes as words is still useful even when the alphabet needs to be much larger than the alphabet of any actual language. This next example turns out to be important. With 25 people in the room, circulate a list of names and have each one write down his or her birthday. There are 25 people in the room. Asking them their birthdays is a 25-stage process. You ask person number 1, what is your birthday? You then ask person number 2, what is your birthday? And this goes on through 25 stages until you've finally gotten up to person number 25. If we're going to represent outcomes of this experiment of asking people their birthdays as words in an alphabet, this persuades us that the words should be 25 letters long. But what about the alphabet? All we need from the alphabet is that there should be as many letters in it as there are possibilities at each stage. Well, there are 365 possibilities at each stage, so we could either imagine making up symbols, 1 symbol for each day of the year, or we could live with the idea that each date is a kind of letter, in the same way that numbers on a die can play the role of letters. With all this in mind, please go on to the next video.